Uh, Dear student, just learn something through this clip. I am giving a short note on the topic electronic transition. It is under the umbrella of spectroscopy. That means the technique for identification of compound. Generally, before the spectroscopy, compound identification proceed so long time, means it takes time consumption. But after knowing the spectroscopy, that is the modern technique, short process and good result, it gives the full information about the matter under study. And it is the interaction of matter with the electromagnetic radiation. Means after passing the electromagnetic radiation to the matter, it gives some result: emission, transmission, absorption, scattering, reflection, etc., etc. So we have to remember some radiation. X-ray. Before the X-ray, the highest energy is gamma ray. Gamma ray approach up to the nucleus. X-ray focus on the inner electron. UV visible focus on the outer electron. IR reflect the vibration of the molecule. Microwave rotate the molecule. Radio wave spin or flip the nuclei like this. So for this electronic transition, we have to remember UV visible spectroscopy. It is also known as electronic spectroscopy, since it involves the promotion of electron from ground state to the higher energy state. It is very useful to measure the number of conjugated double bond, also aromatic conjugation within the various molecules. And electronic transition occur in atoms and molecules due to the absorption or emission of electromagnetic radiation, generally UV or visible. The energy change associated with a transition is related to the frequency of electromagnetic wave given by Planck's constant. That is, we have remembered E equal to Higgs nu. In other words, frequency of wave is related to its wavelength and the speed or velocity of the radiation, since frequency is given by C by lambda. So electronic transition cause the emission or absorption of electromagnetic radiation in the form of quantized unit called photon, means radiant energy. It takes place when electrons in a sample get excited from one energy level to a higher energy level. Such transition provide information on the structure of a molecule with many important properties. So let us take one simple example, electronic transition here. This is one model around the nucleus. Electron revolve from one orbit to the other orbit. Electron get excited. And in case of sodium atom, it is 3s electron of the sodium get excited to the 3p. 3s and 3p in the same energy level. This one electron is very active. It represents the valency of the electron. Here, inner electron of sodium atom are more stable. It is the slide argon and normally not interacted with UV because they are stable. So after the electromagnetic radiation interact with this electron, it get excited. And on the other hand, outer electron, this is outer electron, is loosely held and can easily undergo electronic transition. So sodium generally standard sodium atom absorb this much amount of wavelength, and it get excited to the anti-bonding or excited state. Then after the emission, it goes down to the ground state. And this is one example. This electronic transition take place here also. Electronic transition take place. And here, this is what this is what lowest occupied molecular orbital and highest occupied molecular orbital. I mean, lowest unoccupied molecular orbital generally anti-bonding, lowest molecular orbital generally bonding. The excitation take place and goes down this much molecular orbital. Electronic transition in molecule general short representation. And there are three types of electron in the outer shell: sigma electron, pi electron, n electron. And the stability of this electron is in the order sigma, pi, n. N means non-bonding. Among these, sigma and the pi are located in bonding in the HOMO, means highest occupied molecular orbital, lowest unoccupied molecular orbital. This is model, and they form chemical bond. Means this one, sigma and the pi, whereas n electron not involved in general bonding, but when required, it can be involved. And these molecular orbital like atomic orbital can exist in two states. This one I mentioned, HOMO, LUMO. HOMO higher energy occupy molecular orbital that correspond to general ground state, whereas lowest unoccupied molecular orbital excited, it represent excited above the ground state. An electron in HOMO can jump from to LUMO when required energy in the form of electromagnetic radiation is supplied. Means when the required energy absorbed, the excitation takes place. This is the model of HOMO and LUMO. Head overlapping. This one head overlapping. This is HOMO bonding, and this is LUMO anti-bonding in the p orbital. And this is also p orbital. For example, HOMO, LUMO. And this is the model of LUMO, and this is the model of HOMO anti-bonding, bonding. Some model and excitation here take place pi to pi star. This one is pi bonding. This one is sigma bonding, because head-to-head lateral overlap, as you know from the previous standard. One important point to be noted: important list of different type of electronic state in a molecule and the corresponding transition. There are three model. This is two bonding, MOs, sigma and pi. Two bonding, MOs, sigma star and pi star, and one non-bonding N. The order of energy order of this electron in this order: sigma more than sigma pi star, and pi star more than n more than this one pi, and pi more than sigma. Sigma is the lowest energy. So up to this short note, try to understand some electronic transition. Further, I will give in detail information. This is energy diagram of electronic transition, a possible diagram. This is what this is sigma, pi, n, pi star, sigma star. This group represent anti-bonding, and these represent the bonding. This is non-bonding. The energy order, this is the excitation, this is the transition model: sigma to sigma star, pi to pi star, n to sigma star, n to pi star. This is the order of energy, sigma to sigma star, IR, n to sigma star, next, and pi to pi star, next, and then